I am Saptarshi Mukherjee, and today I'll be discussing the analysis of stock market predictions based on several deep learning models. So I'll be using LSTMs, the LSTM GRU hybrids, CNN LSTM hybrids, bidirectional LSTMs, and several of their combinations. So at first I perform some hyperparameter tuning for the CNN LSTM and the CNN bi LSTM hybrid models, as there were a lot of parameters to be tuned. So I'll be going straight to the results, displaying the results. So what I got was that the bidirectional LSTMs generally perform the best for Dow Jones, followed by the CNN LSTM and hybrid, and the bi LSTM CNN hybrid. And this pattern was seen repeated for most of the other stock indices as well. For IXIC as well, there was the same pattern where bidirectional, bi LSTM, CNN and CNN LSTM all performed very similarly. One thing to note is that CNN LSTM hybrid gave this performance at k equal to 60, while the other models gave it at k equal to 10, which means that it only took the data for the last 10 days. So now for GSPC, the same pattern is repeated. Similarly for W5000 and for XLK as well. In fact, for XLK, the CNN LSTM hybrid is actually the best performing model, and it does that for k equal to 60. So these are some of the graphs for several of the predictions. Now I'll be discussing the performance of these models for specific sector stocks like healthcare stocks or technology stocks or automotive stocks, and see how their predictions are different. So for healthcare stocks like AMGN, we see that bidirectional is once again the best performer, followed by CNN LSTM hybrid and bi LSTM CNN hybrid. Similarly for ABBV, the same performance is repeated, but one change is that the LSTM GRU hybrid also appears to perform quite well. It is the third best performing model. But on the whole, we find that bidirectional is still the best performing model, and it uses only the last 10 days data. And we see that the predictions are a little noisier compared to the predictions on the overall stock indices like Dow Jones, and the reason for that is because individual stock models are generally, individual stock prices, they are generally more noisy compared to entire indices, so the error is slightly more in this case. Now for healthcare stocks, for example, for Intel, we find that the best performing model is once again bidirectional, followed by the CNN LSTM hybrid, this time with k equal to 30. So this could mean that perhaps the Intel model is a little more noisy. That is why there is a lower value of k. Earlier we were using k equal to 60 for this particular model. Similarly, we can see that for Amazon as well, best performing model is bidirectional LSTM, followed by the LSTM GRU and the CNN LSTM hybrid, once again at k equal to 30. And for Meta, we find that CNN LSTM is a decent performer with k equal to 60, but the best performer once again is bidirectional. And the conclusion we can draw here is that the CNN LSTM appears to use larger values of k because tech stocks are generally a little more noisy compared to the overall stock market indices. Now for automotive stocks like Tesla and General Motors, once again bidirectional performs the best, but now LSTM GRU hybrid is also a significantly good performer. You can see similar results for other automotive manufacturers as well. For example, Ford Motors, where we see the same pattern, bidirectional best followed by LSTM GRU. So the combination of LSTM GRU appears to work quite well for automotive stocks. And finally, I would like to come to the aerospace stocks, where we see that once again bidirectional is the best performer, followed by others like CNN LSTM hybrid and bi LSTM CNN hybrid, and we see the same pattern for Boeing as well. So once again, these predictions are a little noisier compared to the overall stock market indices. So the overall conclusion is that error is quite low for overall stock market indices, but it can be a little bit higher for other sector stocks. But the performance of the models, even if the sector of the stock is different, is on the whole quite similar.